You really don't want to download and use Docker containers without checking them first with Docker Scout. So don't just pull Docker containers and use them. Make sure that you check them for CVEs and vulnerabilities with Docker Scout. You also don't want to push Docker containers that you haven't checked because you may be using software that has vulnerabilities in it. I also love this picture that shows how modern software is reliant on a piece of code that someone has created. Just think about Log4j. Great example of how many systems were impacted because of problems with Log4j. Little piece of software that a lot of systems used. But let me show you an example. In Docker Scout, I'm going to search for Mongo. Mongo, 1 billion downloads. I'm going to pull the latest Docker container. I'll analyze it now through Docker Scout. Notice the vulnerabilities in this. 2 critical, 29 high severity, 15 medium severity, 13 low severities. Let's look at the packages and the CVEs. Now, this isn't old software. This was created a month ago at the time of this recording. There are 71 vulnerabilities in this Docker container. Notice here, CVE 2023. This has a CVE score of 9.8 out of 10. Here's another one, 9.8. And we have 29 CVEs, 7.5, 7.8, and so forth. You may think, it's fine for me to pull this Docker container because there have been so many downloads of it.
Why not?
But be careful. And notice this is a 2023 CVE affecting this Docker container. This was updated 9 days ago. We can see that the fixed version here is 1.19.9 for standard library. Look at the CVE. We've got a description of the CVE. We can see that this was updated 9 days ago. We can see that the fix for Golang is 1.19.8. CVS score 9.8. This is a problem. Don't believe that just because this Docker container has been downloaded a billion times, that is used by many people, that there aren't CVEs or issues with the Docker container. Let's look at Mongo Express. I'll pull that container. 100 million downloads on this container. I'll go to Docker Scout, have a look at Mongo Express latest, analyze the image. Notice it has 1 critical severity vulnerability, 3 high severity vulnerabilities. Again, if we click through, we can see the information about it. So this CVE 2023 45133 shows us problems with software used within this Docker container. This has a 9.3 CVE score. Okay, so that's just 2 examples of Docker containers that have been downloaded many times, but have critical vulnerabilities in them. Docker Scout allows you to understand your application's dependencies. So it's not just for people who are using Docker containers. It's also for developers who are creating Docker containers. How do you know that the dependencies that you're using as part of your application don't have CVEs? How do you analyze for vulnerabilities and act quickly with suggested remediation options? So in this video, I'll show you this Docker container that I'll create, and I'll show you the issues with the Docker container and then how to resolve the issues in the Docker container. So as you can see here, my Scout demo v7 Docker container doesn't have any issues, but that's not how it started. When it started life, it had 2 critical severity vulnerabilities, 16 high and 8 medium severity vulnerabilities. We can see through Docker Scout the fixable and critical high vulnerabilities. The goal is to get to the point where we have 100% compliance with copyleft licenses, that we're not using root users for our Docker containers. That's a common problem. That the critical and high vulnerabilities have been fixed. High profile vulnerabilities have been fixed. We're not using outdated base images, and we have supply chain attestations in our Docker container. So here I have 100% compliance. That's where I want to go to. Not always possible. So this is the goal. Look at the Docker containers that you're creating and make sure that you're not making common mistakes like using a root user, or that your code or your dependencies have vulnerabilities in them. What's great about Docker Scout is there's a free plan, unlimited local image analysis for remote images up to 3 repositories. You've got a team option at $9 a month, and then there's a business option. I really want to thank Docker for sponsoring this video and creating this software because it's a big issue today. People are using containers all over the place, but are not always aware of the vulnerabilities in those containers, and developers who create vulnerabilities and use software, again, famous one being Log4j, are not aware of the vulnerabilities and critical CVEs in their software. Now, in this video, I'm going to show you a bunch of options. Some people may be commenting already, David, why are you using Windows? I'm just using Windows for this demonstration because a lot of people use Windows, but this could also be used on macOS or Linux as an example. Others of you may be commenting saying, why are you using a GUI application? I want to use PowerShell, or I want to use the CLI. I'm going to show you how to use those options in this video as well. But to help you, my team and I have created a PDF which you can download using the link below. Use this video as a reference guide, but also use the PDF if it helps you. In the PDF, it shows you as an example how to install Docker Desktop on a Windows computer and how to install Git on a Windows computer. So I'm going to show you that now. But if you're not interested in seeing how to install this software, then jump to this timestamp where we get into the actual demonstration of the product and show you how you can fix vulnerabilities and CVEs in your Docker containers. So the first thing we need to do is install Docker Desktop. So from our PDF, which I've linked below once again, you can click on this link or simply go to docker.com, products, Docker Desktop. I'm going to download Docker for Windows. As you can see here, they have options for Mac as well as Linux. Mac includes both options for Intel as well as the M chips, but I'm going to simply download for Windows. It's about 476 meg in size. While that's downloading, I'm going to download Git as well. So I'm going to go to gitscm.com and I'm going to download that for Windows. So click here to download the latest version. And as you can see, that's downloading. It's about 64 meg in size. Okay, so the software has successfully downloaded. I'll go to the directory, double click on Docker Desktop Installer, say yes to install the software. Now in this example, I'm using the home version of Windows, so it's going to use WSL. But if you're using a professional version of Windows, you could either use WSL or Hyper-V. So choose whichever option you prefer. In this example, I'm just going to click OK to complete the installation. So as an example, notice here it says use WSL2 rather than Hyper-V. Okay, so once the installation is completed, you need to click close and restart your computer. Once Windows has rebooted and we've logged back in, we need to accept the Docker subscription service agreement. So I'll click accept. But just before I do that, notice Docker Desktop is free for small businesses, fewer than 250 employees and less than 10 million in annual revenue. Personal use, education, and non-commercial open source projects. Otherwise, it's a paid product. So I'm going to accept the license. And then we're told, do we want to use advanced settings or recommended settings? I'm going to go with recommended and click finish. I'm going to allow the app to make changes to my device. And now you can either sign up or you can sign in to Docker Desktop. I'll install Git by double-clicking on the executable. I'm going to allow Git to make changes to my computer. A lot of options here, but I'm simply going to press next, 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 next to install the software. So a whole bunch of options available. But for a very basic install, I'm just going to go with all the defaults. So just click next, 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 and click install. You can read the release notes, but I'm not going to do that. I'm going to simply launch GIT BASH. There you go. I've got GIT BASH running on my computer. So pwd as an example shows you where I am in my directory structure. Okay, so I have both Git Bash installed as well as Docker Desktop installed on my computer. Okay, so now that we've got the installation completed, we can get into the nitty-gritty of the Docker Scout software. Now, one of the things you need to be aware of is Docker Scout uses a software bill of materials. It knows what's part of the Docker container. So you don't have to keep on scanning your Docker containers to make sure that there are no vulnerabilities in them. Massive benefit of Docker Scout. Okay, but let's demonstrate this because that's going to be more fun. What I'll do is open up PowerShell and use the command Docker software bill of materials help to see the various options here. So as an example, for an image, we can see a summary of discovered packages. We can write a report output to a file, various options available. Okay, so let's have a look at the software bill of materials for the latest Mongo container. So what this is going to do is it's going to pull the container and then analyze it. So it may take a while for the output to show, but there you go. We can see for apt as an example, the version and the type. It's a Debian package. We can see a whole bunch of software and dependencies in the bill of materials. Now that's nice, but we might want to output that using the system package data exchange format. So I'll clear the screen again. Okay, so what we're doing once again is pulling the image, analyzing it, and then pushing the output to a file. So dir here, we can see our JSON file, and opening that up in Visual Studio Code, you can see the software bill of materials right here. As an example, package manager, we can see the Ubuntu distro 2204. There's a whole bunch of information available in the software bill of materials. Now, once again, the big difference between Docker Scout and other vulnerability scanners, which form part of your CI/CD pipeline, is that with other systems, you get a snapshot of the vulnerabilities when you run the scan, which is essentially a static snapshot of all the vulnerabilities at the time that you ran the scan. But that's not constantly updated. You'd have to keep on running the vulnerability scan whenever you update your image. Docker Scout, however, uses an event-driven model. With its image analysis, it extracts the software bill of materials and other image metadata and then evaluates it against the following advisories. So you could go to this page as an example, docs.docker.com, Scout Advisory DB sources, and it shows you the various databases that are used to check if there are any CVEs or vulnerabilities in the image. What's great about this is the continuous process of comparing vulnerability data against the image software bill of materials leads to finding new vulnerabilities as they are announced, and these vulnerabilities show up on the Docker Scout dashboard. You can also add your own internal advisories to the mix, ensuring that you have the most complete vulnerability scan for your project. The big goal here is to worry less about vulnerabilities and focus more on your code. Now let's go through a demo showing you how you can use a Scout Docker image and look for the vulnerabilities and then fix them so that you go from, in my example, V1, I went through many iterations of this testing various things, to V7, where I had no vulnerabilities. Hopefully it'll go a lot quicker this time around, and I'll show you how you can quickly and easily fix vulnerabilities in a container. First thing I'll do is run git bash as an administrator. I'll say yes, and here we go. Make it bigger. I'll move into my Docker demo directory, and then what I'll do is clone the Docker Scout demo from GitHub. So ls, there we go. So I'll move into that directory, ls again. We can see package information. You can see various files, including Dockerfile, package.json, and so forth. Now, just be aware that various integrations are supported, so you can connect to third-party projects to extend Docker Scout functionalities into your software development lifecycle. So as an example, we've got Docker Hub, which I'm demonstrating, but we've got Azure, we've got Elastic Container Registry, we've got GitLab here, we've got Jenkins, and so forth. Whole bunch of options available with Docker Scout, including team collaboration with Slack or Teams. Okay, but let's get back to the code. So I'll clear the screen and let's use Docker login to log in. So it says here, authenticating with existing credentials, login succeeded. How did that work? It works because I'm logged into Docker Scout using the Docker desktop. So if this login fails, make sure that you've got Docker desktop downloaded and running and that you've logged in to your account. Now, I already have a Scout demo repository. So let's change the name slightly here. So I'll call this Scout demo 2 v1. So what I'm going to do is build my container and then push it to my account, but I'm going to call this Scout Demo 2 v1 just because this has tripped me up. Notice you need to put a dot or period if you prefer at the end there. So I'm going to press enter now and notice it's busy building it and we'll push it to my organization. So you can see here it's busy pushing it and that's now completed. Okay, next thing we need to do is enable Docker Scout on the repository. So we use the command Docker Scout repo enable organization name and then the repository. And we can see now that Docker Scout has now been enabled on that repository. We can now manage it through the Docker Scout dashboard, and they give us a URL to the Docker Scout dashboard. I already have that open, but let's use their link. And as you can see here, we've got Docker Scout demo created 5 minutes ago, and Docker Scout is active on this repository. Now, if I click on overview, I can see that my values have dropped now. So default non-users 50%, critical and high vulnerability issues 50%. So one of my images complies, one image doesn't comply. Supply chain attestations, also only one image complies. So if I click on vulnerabilities as an example, we can see that in Scout Demo 2, pushed 7 minutes ago, there are 20 vulnerabilities. This is not good, including CVEs with a score of 9.8. So we've got 2 CVEs with 9.8, and we can see details of this, we can see here that buffer overflows can be used. 9.8 CVE score, very, very bad. So going back to overview once again, notice we have fixable, critical, and high vulnerabilities in this image. If I click on V1 here, we can see at the top here, we have 2 critical severity vulnerabilities and so forth. Notice the image hierarchy on this Docker container. Here are a whole bunch of problems. And once again, if we click through, we can see the various CVEs. So as an example, 9.8, or what about 7.5 here? We get information about the various CVEs, but you probably don't want to spend all your time reading about the CVEs. You want to solve this problem and get the container updated. Before I show you that, once again, through Docker Desktop, I could search for something. So in my private repos, I can see Docker Scout here, which I could pull. So this is Scout Demo 2. Notice the original Scout Demo V7 has no vulnerabilities, but if I look at Scout Demo 2 V1 and analyze that, I can see very similar information as I saw online. So here's the desktop application. Here's what it looks like online. What you may find is that Docker Scout Online will give you more information than Docker Desktop. So make sure that you look at both versions when trying to investigate vulnerabilities. Okay, but on Docker Desktop, I'm going to go to Docker Scout. Once again, go to Demo 2, V1, view the packages and CVEs. And at the top here, notice we've got options for recommended fixes. So not only are you seeing issues, which is okay, but you want to know how to fix images. So let's go to the recommendations for the base image. So we're told here's an example to change the base image. We can see the current image, and then we can see updates to the image. So as an example here, 3.19 was updated 4 months ago. Now what's interesting is the information shown here is good, but you may worry about the medium severity CVEs. And this is where the CLI gives you more information. So in the CLI, I'm going to use the command Docker Scout recommendations. This is in PowerShell. And notice we can see base image is Alpine 3. We can see critical vulnerabilities, etc. And scrolling down, and notice here we can see the latest release is 3.20. In the Docker Desktop application, we can see a minor update being 3.19, and then we can change this code in the Dockerfile. So not only are we told the issue, but then we're told how to fix our file. So what I'm going to do here is I'm going to update the Dockerfile to 3.19, but then run it again to show that we can update it to 3.20 to get rid of all the CVEs. So I've opened my Scout demo folder in VS Code. And if I go to the Dockerfile, notice at the top here, that's what we want to change. So I'll delete that and I'll paste in the recommendation from Docker Desktop. So literally just copy this from Docker Desktop and update the file. It even tells us what to do here. So replace your old tag with this new one in your Dockerfile. So I'll save that. Okay, so what I'll do now is build and push my updated Docker container, in this case V2, to Docker Hub. And there you go, it's busy building. Okay, that's done now. So in Docker Scout, under images, I can see Demo 2. I've got V2 here. So I'll click on V2 here, the most recent image. I'll go to Fixable, Critical, and High Vulnerabilities. Click on my image V2, and notice we can see that there's an issue in Express. So we've got a 2024 CVE here and details about that CVE if you want to read about it, but we're not going to worry about that here. What we want to do is fix this. So back in Docker Desktop, I'm going to search for Scout. I'm going to pull version 2. Go to analyze that. I'm going to analyze the image. Notice once again, 2 high severity vulnerabilities, 5 medium. Click on View Packages and CVEs. Go to Recommended Fixes for the base image. Change base image. And notice we're told to use 3.20, which is the latest release. Now, this was updated 7 days ago. At the time of this recording, our unspecified CVEs go down by 2. We need to change this code. So I'm going to copy that back in Visual Studio Code. I'll change Alpine from 3.19 to 3.20. Save that. I'll build and push this to Docker Hub, but as version 3. Okay, so that's now being pushed. Now back on the Docker Scout website, unfortunately, we still have 2 vulnerabilities. So in our V3 image, we still have vulnerabilities. Notice here, Express 4.17.1. CVE score 7.5. If I go to the Docker desktop and pull version 3 of the demo and then analyze that image, we can see something similar. 2 high severity CVEs, Express 4.17.1 has a problem. Now, an issue here is when I look at recommended fixes, notice no recommendations are available at this time. So that's a problem. How am I going to fix this? So going back to the website, let's have a look at the actual CVE information. So CVE 2022-24999. What are we told here? The fixed version is 4.17.3. Affected ranges are below 4.17.3. npm.js. If we go and look at the actual npm.js website, we can see version 4.19.2 here, published 2 months ago. 4.17.3 fixes it, but the latest release is 4.19.2. What does the CLI show us? So if I run Docker Scout CVEs, we should see something very similar. Notice 2 high, 1 medium vulnerability in packages. We can see the analyzed image once again, 2 high, 1 medium. Express 4.17.1 has an issue. Here is the CVE information once again for the high vulnerability. And here's the CVE information for the medium vulnerability. So there are a lot of options here. You could use the website, you could use Docker Desktop, or if you prefer, use the CLI to find out similar information. But the most important thing is, how do I fix this? So under package.json, we can see dependencies here being Express 4.17.1. That's the problem that we found with Docker Scout. Again, this package has a CVE score of 7.5. And then once again, you could just click here to see information about the CVEs directly within Docker Desktop. Okay, so what we're going to do here is change this to 4.19.2. So change to the Express dependency to that version. And what I'll do is change the version to V4. Once again, it's V3 that has the problem. Okay, so build and push to Docker Hub. Okay, so that's now completed. Go to the website, click on Overview. Now that's what we want. 100% for our fixable, critical, and high vulnerabilities. There are no issues or no vulnerabilities at the moment. So that's great. In Docker Desktop, let's pull version 4 under Docker Scout, version 4, analyze it. The result we want, no vulnerabilities. Everything is clear. Back on the website, look at images, version 4 of our demo, no vulnerabilities. We, however, only have a 3 out of 6 compliance, whereas my version 7 of the previous demo has 6 out of 6. So if we look at compliance, we can see that default non-root user is not compliant. Click on details. Ensures the image specifies a non-root username for the final stage. We haven't done that here, so that's a problem. We also have issues with the supply chain attestations. If we look at details here, stuff is missing. So going back to overview, we may have 100% here, but we're only getting 50% on default non-root user and our supply chain attestations. So we need to fix those as well. Okay, so within VS Studio Code, I'm going to go to Dockerfile, and we need to add some details here. Okay, so first thing we're going to do is create a group and a user. So we're going to use this command, once again, to create a group and a user. We're going to change the working directory of the app, and we need to change the ownership of the working directory to the non-root user. So notice we're changing the ownership here, and we're switching to the non-root user. So again, we've created a group and a user. The working directory is going to have its ownership changed to the non-root user. And we're going to switch to using the non-root user. Okay, I'll save my changes. And let's build version 5 and push that to Docker Hub. Okay, so that's now been done. On the website, click on Overview. We had default non-user being 50%, and now it's 100%. So we've solved that problem. 100% for copyleft licenses, default non-user, critical and high vulnerabilities, high-profile vulnerabilities, outdated base images, but we've got 50% for supply chain attestations. So my V5 is still not fixed. So we need to fix these 2 violations. And again, we can look at the fixes on how to solve this. Back in Docker Desktop, let's pull version 5 of our app. Go to Docker Scout, version 5, analyze the image. No CVEs here, but if I click on the cog at the top, scroll down, make sure that you've got this checked. But if yours is unchecked, check it and then click Apply and Restart. So once again, just back in the overview on the website, notice we're getting 50% here because this V5 image doesn't have the supply chain attestations fixed. You have to run the following command to ensure that your artifacts have both the SBOM and provenance attestations. So let's run that on V5, which is the current version that we've got. You can see that that's successfully run. Okay, so there you go. We have 100% compliance, copyleft licenses. We're not using a root user. Our vulnerabilities have been corrected. There are no critical and high vulnerabilities in our containers. Our supply chain attestations have been fixed and so forth. This is what's fantastic about Docker Scout. It makes sure that the containers that we are using, and all of us use containers these days, whether we know it or not, are secure, and that the containers that developers create are better secured. Big shout out to Docker for sponsoring this video and making the world a safer place through the creation of Docker Scout. I'm David Bombal. I want to wish you all the very best.